Hello, everyone. Thank you for joining in, and welcome to reInvent, scaling .NET application with asynchronous workflow. My name is Ashish Bhatia. I'm a senior specialist solution architect at AWS. I've been doing .NET for 20 plus years.
My name is Norm Johansson. I'm a senior dev at AWS, where I focus on all of our AWS .NET tooling.
So here is what we're going to cover over the next 60 minutes. We're going to start off with why we should build an event-driven architecture. Here, we are going to specifically talk about challenges with an API-based integration. Then, we're going to talk about 3 Amazon services. Amazon SQS stands for Simple Queue Service, Amazon SNS, which is Simple Notification Service, and third will be Amazon EventBridge. Then, we're going to pivot and talk about observability. And here, we're going to talk about OpenTelemetry standard, along with AWS X-Ray service. Again, this session is going to be heavy demo focus. So you'll actually see a lot of .NET code in action that will demonstrate how to integrate with these services. Our objective that as you walk away from the session is to see how you can use the .NET SDK to integrate with the 3 services that we talked about. And secondly, you can see how easy it is to build distributed application on Amazon platform. So if you have made the move to microservices, this picture may look familiar. So here we have a simple example where a client is making a call to an order service. The order service turns around and makes a call to the invoice. The invoice sends a response back and sends it back to the customer. Now, this works great when we have a simple system like this. But let's say in the e-commerce application, you start adding additional services. So on this slide, we have added 2 additional services along with invoice. We have got fulfillment and the forecasting service. And you can see here, the order service is acting as an orchestrator. It is responsible for gluing all these 3 different services together. So let's talk about what are the challenges in an API-based integration, even though your organization may have gone down the microservice route. Firstly, there's a tight coupling between a producer and a consumer. So the producer in this case is an order service, and the consumers are all the downstream services. Now this makes it difficult to evolve new architecture. So let's say your e-commerce application is growing, and your organization decides to add a new service called notification. That every time an order gets placed, you want to send a notification back to the customer. With this design, when I add a notification service, you'll have to go back and make a change to the order service. Secondly, the order service is acting as a single point of failure. If the order service goes down, your entire business process is going to fail. The order service also needs to account for the retry logic and error handling. So for example, if the fulfillment service returns an error response back, the order service needs to look at the error, build that logic to retry, and the retry logic would be staggered based on the quality of service agreements between the fulfillment and the order service. Another big challenge that we have seen with the API-based integration, we just had Black Friday in the United States, the biggest shopping event. So let's say there was a sudden influx of orders that came into the order service. And assuming order service was running on Amazon AWS platform, it scaled well. But for some reason, the invoice service did not scale to the same level of the order service. In that case, the invoice service is going to start rejecting requests and is going to drop your orders on the floor, which is impacting your downstream revenue. So let's talk at how we can solve the challenges with an API-based integration. So in this section, I'm actually going to talk to you about the pattern called asynchronous point-to-point using a queue-based integration. So as you can see, we actually have a sender and a receiver. But what we have done, we have actually introduced a queue in the middle. The sender is pushing the messages to the queue. The receiver is polling the queue, saying, hey, do you have any work for me? Do you have any messages sitting in the queue? As the messages arrive in the queue, the receiver gets a message, It does its processing and sends an ACK back. I would like to emphasize here, the receiver is actually coming to the queue, grabbing the messages, and once it's done processing, sending an acknowledgement back. A very common scenario in a queue-based integration is that a receiver is trying to process the message from the queue, but it encounters an error. Now, this could be for a variety of reasons. A common example could be the message format is not correct. It's trying to make a call to a downstream service that is not available. Or it's actually making a call to a database and the stored procedure did not work correctly. What do we do in that scenario? From a best practice standpoint, after X number of retries, it's important to park that message because you do not want to burn your CPU cycle on keep on retrying an error message over and over again. So in a queue-based pattern, that's called dead letter queue. Okay? To implement a queue pattern on AWS, you can take advantage of Amazon's simple queue service. It is a fully managed message queue, and that means there is no infrastructure to provision, there's no software to install on an EC2 instance. Once you spin up an SQS queue, Amazon is actually going to make sure the infrastructure behind the scenes to run that queue mechanism is already provisioned for you. It scales infinitely, and you don't have to worry about scaling or adding additional servers. And it provides a simple API to interact with the queue. And this is what we are going to see during a demo, where Norm is going to show us how you can use the .NET SDK to talk to the SQS service. It does offer a dead letter queue support by default. And it actually gives you two options, standard and FIFO. So FIFO stands for first in and first out. So let's say you're building an application where you need ordered delivery, sequential processing, and guaranteed delivery to you. That's where FIFO is going to come in. So if you see here, the sender is pushing messages A, B, C, and D to a queue, and we want to make sure all those messages get processed in the same order. That's when you're actually going to use FIFO queue. A common example is for an e-commerce application, you need to apply pricing updates. All those pricing updates need to be applied sequentially, and that will be a good use case for FIFO queue. Now, what happens within your application, not every message needs to be processed sequentially, because that's actually going to cause issues from a performance standpoint. So to give you an example, in an e-commerce application, you're actually managing user updates. All the changes that actually belong to a single user should be processed sequentially, but the changes across the user base could be processed in parallel. And that's where you will actually leverage this concept called message group ID. So here we actually have 4 messages going from a sender to the queue, A, B, C, and D. You want to make sure A and C gets processed sequentially because they belong to the same user, and B and D gets processed sequentially. The way to do that on SQS is taking advantage of this concept called message group ID. So what we have done on the slide, you can see A and C have been grouped as X, and B and D has been grouped as Y. So when you are actually pushing a message in a FIFO queue, you need to specify a message group ID. So the messages that belong logically together, you can give them a message group ID, and when the receiver tries to process the message, it's going to ensure those messages that belong to the same message group ID are processed sequentially. Okay. So let's take a look at a demo.
All right, Ashish, can you switch to the next one? There we go. So I thought what we'd do for talking about SQS and .NET is I'd tell you about what how my team uses it. My team is the AWS SDK for .NET, and we use SQS to actually deliver the .NET SDK to all the .NET developers who want to access AWS. In fact, my organization is in charge of delivering SDKs for all of the AWS SDKs out there, which I think is at 12 right now. So what we have to do in my organization is we go and work with all of the AWS service teams. We have over 300 and some service teams that come to us and they say, hey, I'm S3, can I have a new change to my service, or DynaDB or EC2? And what they do is they come to our release orchestrator. And our release orchestrator, it allows them to basically say, this is my model change. We'll do a lot of validations on that, and we'll generate them some preview builds. They can then go and test those out. They can also say, when do I actually want to have this be released? You know, like this week is very busy for this system. So, you know, a lot of service teams are saying, I want to go out here. And so mostly once a day, this system collects all of the services that say, yep, I'm ready to go. And it sends messages out to all of the AWS SDK's teams and say, go put out a new version of the SDK. And we use SQS as that layer for the release orchestrator to communicate to all of the SDK teams via their SQS queues. All right, let's switch over to code and see a little bit more what I'm talking about. So here I'm in Visual Studio, and for clarity, you know, for truth, this is not our actual build release system. Our actual build release system for the .NET SDK is a very large system that's communicating with a lot of other internal systems. But I've taken out all of the important pieces from that for our demonstrations about how we are actually using these AWS services to build our SDKs. So first, let's talk about how that release orchestrator would send messages out to the SDKs. So here I have some code here for publishing messages. So here's a message for sending a preview message or a release message. So when a service team comes in and says, hey, I want to do a new change, it will get a message sent as this preview message, and it'll get sent to all of these queues. Now to send a message, you use all of our services. We have a service client. Here I've created the SQS client, and we have a send message API. Now for that, we pass in a request object, which identifies which queue we want to actually send our message to, and then the message that we actually want. In this case, I have taken my preview message .NET type and just serialize that to JSON and set it to our message body.
So Norm, I see that you're actually serializing a message in JSON. Are there any other formats that this SDK can accept other than JSON to send the message to SQS?
Yeah, so message body actually here is just a string. From SQS's point of view, a message is just an opaque string. Convention is most commonly to use a JSON string, but if you have your own custom formats, you're doing XML or whatever it is, all that is fine. We just do JSON as probably the most conventional way to do it.
Okay, cool, thank you.
Now, Ashish just talked about message groups with FIFO queues. So we might have a scenario where, let's say DynaDB comes into our system and they say, oh, we want to do a new change, and they submit our new model change to us, but they forget the docs, and they immediately go run over, add the docs, and send it in. Now, in a standard queue, we might get those messages in any order. The order is not guaranteed, and we want to make sure we're processing the messages for a particular service in the order they give us. Now, I don't care the order between a DynaDB and S3 and EC2. Those can be done in any order, and that's how we can scale the system. We can parallelize those builds as much as we want to, depending on how much compute we want on there. So we specify the message group ID to be the service name so that we know that we're just going to do the ordering on a per service basis. Now I also add some attributes onto the send request. So these attributes are the build type and the build ID. I think this is going to be passing whether it's preview build or not. And this is really useful for the code that's going to read this message, because that code can just easily look at these attributes and say, oh, this attribute says the build type is a preview. It knows which code to forward it to, and it now knows the format of this message body. Because a release message and a preview message have a different format. But we can easily find that out just by checking the attribute. We don't have to crack open that opaque string and figure out what it is. So this is how we send messages. Let's take a look at how we actually process our messages. So we have our message processor. Now our message processor is something that we could run in a container. And how we would scale this is we would just spin up multiple instances of this container. And this process is basically an infinite loop. It's just going over and over forever, trying to receive messages from our SQS queue. Now, if we look at the parameters that go into our queue, again, we're identifying which queue we want to read messages from. And we're also saying we want to wait up to 20 seconds. Now, this is what SQS calls as long polling. And this is really important when using SQS. Because by default, if there's no messages in the queue, that receive call that we have down here will return back right away. And as we see, we're doing an infinite loop. So it'll just go really over and over again really, really fast, just wasting up your CPU cycles if there's nothing in the queue. And also, one of the price factors of using SQS is how often you make API calls. Now, by setting this to 20 seconds, what we're saying to SQS is hold on to this connection for at least 20 seconds. If any messages come in that time, then return it. It doesn't mean it will always wait 20 seconds. If there's messages in the queue, it will return back right away. But by having this, we're basically, if the queue is empty, we're only going to make about 3 calls a minute. Versus if we don't have that, we're going to make as many calls as our CPU is going to allow us to do. So very important for that to do that. Now, SQS does also support batching. And on that receive call, I can receive up to 10 messages at a time. And there are also corresponding batch send methods and batch delete methods. Now, in my example, my messages to process them are very CPU and disk IO intensive. I have to do all of the MS build work, Git cloning, all these things. They take a long time. It's not worth it in my situation to try to parallelize multiple messages in the same container. I'm going to scale this by spinning up multiple instances of my container. Now, if your messages are more lightweight, something that's just waiting on downstream services, this is where you'd really want to parallelize processing those messages to get much higher throughput through your queue.
So Norm, you talked about batching in terms of pulling more than one message from the queue. Mm-hmm. How do we ensure that the same message is not getting processed multiple times to avoid duplicate processing?
Right, because we said we have multiple instances of this container, and they're all calling this receive message. And what we don't want is one container to pull a message and another one to pull it as well, and then we're doing the build twice. We don't want to send 2 releases out in a day. So what we specify up here is the visibility timeout. And right now, that visibility timeout is set to 60 seconds. What that means is when I get this message back from this received call, I have 60 seconds to do all my processing work and delete that message. That's that acknowledgement that Ashish was talking about, is I've said I'm completing it, go ahead and delete it. If I don't complete that work within that time, then SQS is going to assume something happened, and it will allow it to start coming back in more received calls. Now, reality in my case, it takes a lot longer than 60 seconds to do these builds. Our release builds take about 3 hours to do. Now, what we do is we do a little bit of intelligent management of our visibility, where when we start processing our message, we keep monitoring that task, that .NET task. Are you still running? If you're still running, keep changing the visibility for another minute. We do this instead of saying the visibility should just be 3 hours, the max time, because if we have some sort of transient failure, for whatever reason the container crashes, if we set that visibility to 3 hours, we're not going to get a retry of that message for 3 hours. This way, we'll get a retry of that message in about a minute or so. All right, so this is how this is our flow of processing messages. Let's kick this message processor up here in Visual Studio. You can see it's starting up, and it's pinging SQS for new messages. You can see it's doing that long polling. It'd be screaming, pinging all the time if I wasn't saying wait for 20 seconds. Now, if I switch over to my console application, which is going to pretend to be our release orchestrator, I can say, let's go send a release message. And that long polling immediately returned back. We're ready to start processing that message. So we can go through here. We got all of our fun logging and everything. We're going to do actually, I'll process this message. And here we can see this is where we're going to check our attributes. I don't know what the message body is yet, but I can look at those attributes and see, oh, I'm doing a preview build. Now I know what this format's going to be, and I can forward it to the right piece of code in our system to handle preview builds. So I can just kick that off, and we should see that we've got a fake version of the build going on right now here. So this is how we actually use SQS to get messages about when we need to do our releases for the .NET SDK.
Great, thank you, Norm. So quick recap of what we covered in the demo. We did take a look as to how we can use a .NET SDK library within C# to to do a send, receive, and delete message. We talked about how we can intelligently manage the visibility of the messages that are sitting on the SQS. Now, the pattern that Norm showed, I think that's being used internally within AWS to process messaging. We did talk about the FIFO queues with message group ID. That's another critical aspect that we have seen our customers taking advantage of when they need current order delivery or sequential processing. And we briefly talked about the batching, that when you actually go and talk to SQS, you have an option to grab more than one message. Like I had worked previously or talked to customers where they're actually processing millions of messages passing through SQS. Pulling one message at a time is not a scalable mechanism. That's where they actually grab more than one message, up to 10 at one point, use long polling. So when you actually go to SQS, you actually want to make sure that you have a long polling setup where it goes to the SQS queue, tries to pull the message, but if there are no messages actually going to sit out there. And that's a more efficient and cost-optimized way of interacting with SQS from .NET code. So the next pattern that we're going to talk about to build distributed application is pub/sub. And in this architecture, there are two primary actors, publisher and subscriber. So publisher-subscriber is a messaging pattern in a software architecture where a publisher sends a message to a predetermined location. It is typically called a topic. Once the message gets to the topic is actually going to send that message out to one-to-end receivers. So I would like to emphasize here we actually have a topic in this design which is actually doing a push. When we talked about SQS, it was actually doing a polling using that poll operation that we talked about. The other critical aspect of this design is that the same message can be pushed to multiple receivers. So if you look at the slide, we have M1 and M2. So these actually indicate two messages coming in. We want to make sure that both M1 and M2 goes to receiver 1 and 2. And that's what this pattern allows you to do that. Now, to implement this pub/sub on AWS, you can take advantage of Amazon's simple notification service. It is a serverless pub/sub service. That is, there is no infrastructure to provision, scales automatically, infinitely, and you actually get a pay-as-you-go model. It does support message filtering. So let's say you actually have a message coming to SNS, but you only want to ensure that the messages that go to receiver 1 have an attribute called color attribute of blue, and the messages that actually go to receiver 2 have a color attribute of green. This is what SNS can support, where you define those attributes what Norm showed when we are sending a message on the SQS. And depending on those attributes that you have configured, SNS can do the routing logic automatically. The other aspect is the messages are actually getting pushed to the subscriber, so there's no polling operation involved. SNS supports two different use cases. So you can do application to application. So let's say the message comes to SNS, and you actually want to invoke a Lambda function or an HTTP endpoint. You can easily do that with SNS. In addition, if you want to do application to person, so earlier I talked about that e-commerce scenario where we have this notification service. So let's say the order created event came in to SNS, and now you actually want to send a text notification to the consumer saying, hey, we got your order. SNS has the pre-baked integration where you can send a text message or an email. So let's take a look at the demo of SNS.
All right. You can switch me to the next one. So the last demo, we talked about how our .NET build system is pulling messages from our SQS queue from our release orchestrator. But now we need to complete the loop. We need to go back and tell the release orchestrator that, hey, we are done. We've done the build, and whether it's successful or not. We also might want to, if this was a release build and it failed, this is a case that we need to then page in the .NET team. So like I was on call last week, and we had a build failure, so I quickly needed to get paged in and jump on and see what's going wrong to make sure that we got the release part of reInvent. So with using a topic, we can have these multiple subscribers. We can send the message also to the release orchestrator, and depending on our filter, we can also page in the .NET team to jump on this issue and see what's going on. So let's switch back over. So this is that process message that we were just looking at. So at this point, we've got our process. I have a build status message. If we look at this guy, this has got us whether the build was successful, what type of build it was, and our build ID. And this is what our release orchestrator needs to be able to correlate the message that they send us into the queue to the message they get back to update their system. So we really just need to send this off to SNS. So I already have created my SNS service client, so I'm just going to say SNS. I'm going to publish a message. And so in S, we need to specify our topic, which is coming from my app settings. And I need my message in there. And again, this is just a string. So I am going to serialize our build message into JSON. And I believe I've got a JSON object here because I want to make sure my .NET enums are serialized as strings as I go over the wire. So that's all it really takes for me to send this to SNS. I'm also going to add some attributes, and I don't want to type that in, and I'm going to dumb finger that. So I'm going to go to my cheat sheet here to add my attributes. And if we look at our attributes are basically saying that what type of build this was and whether it's successful. And this is going to make it really easy for me then to set up my filtering.
So Norm, I do see that you actually added attributes before you send the message. Are attributes the only mechanism to do filtering in SNS?
So actually, SNS just launched last week. As we were making our demos, they're like, oh, there's a new thing in the console. So they just added support for us to be able to do filtering on the actual message itself. So I don't necessarily have to use attributes. I'm still choosing to use attributes because in this case, it's very simple for me to do. And when you do that message filtering on the payload, SNS has to actually then parse your message, and there is a slight cost for them to parse that message to do the filtering. So I can save costs by still using attributes in this case. So this is our message being sent. Let's take a look at how our console is set up to have that filter on there. So this is our topic that we've got set up. Right now, it's already got one SQS subscription. This is the queue that our release orchestrator is going to listen to figure out to update its system based off the message it gets from the SDK builds. So I need to add a subscription to page in the .NET team if a release build failed. So let's go add that subscription. I'm going to say protocol. Now, again, for transparency's sake, in my world, we actually would have it being paged to a page. We'd send an email to a paging alias. Doing an email on stage here, it just doesn't demo very well. So I'm just going to actually use a Lambda function as a better way to visualize how we have the filters going in that direction. So I'm going to say Lambda, pick my Lambda function I want it to go to. There we go. And now I can specify that filter. Because if I just push create now, I'm just going to get all the messages. I only want to get called if it's a release build failure. So I'm going to go turn on our filter. And this is that new feature SNS launched last week. We can do attributes or body. I'm choosing attributes, and I'm going to copy paste my filter I want to use, which is saying if the build type attribute is set to release build, and if the result is set to false, not successful, that means we want this message to be sent in. Now, if you're doing message body, the syntax of the filtering is the same. It's just assuming that your message is a JSON document, so you're using that same sort of format.
So now, Norm, what happens if you try to send a message to a receiver in SNS and the receiver encounters an error? It throws an error message back.
So like you mentioned in your slides, how SQS has dead letter queues, we can actually define a redrive policy. And part of that redrive policy allows you to specify a dead letter queue to send those messages in there. And there you can go see, later on, examine the message and try to figure out why it fails. In our example today, I'm not going to use that, but it's just as simple as setting that redrive policy. OK, so now if we look at our topic, we can see we've now got 2 subscribers. One is a Lambda subscriber, and one is an SQS. So let's see this out in action now. So I'm going to start up my message processor again. Spinning up. Okay, it's waiting for messages. And now let's send a preview message. So here's our preview build. And yep, preview. It's going to run that logic. And we can see it's pretending to do a build right here on stage. So if we now go look, I can use the AWS toolkit for Visual Studio. And here's that queue that we had registered. I can look in there, and I can see it got its message there. That SNS published the message there. If I look at my Lambda function that I attached there, and I can look at its logs, there's currently no logs, meaning nothing has happened yet. It hasn't been called yet. If I do a release build, so here's our release build. We're processing it. All right, is this having it release? Let me step through. This is going to fail because the team told me that I'm not allowed to do any release builds while standing here on stage. So we failed there. So now if we go back and look at the queue, we can see now both messages have been on there. And if we look at our Lambda function, we can see that now it picked up the message. The filter made sure, since it's a release build failure, that we should go in and page in the .NET team. However, we implement that logic. So that's how we can use SNS to complete the circle of SQS sent the message into our system, but we broadcasted out the results of it to SNS, to our release orchestrator. All right.
Cool. Great. Thank you, Norm. So a quick recap of what we covered in the SNS demo. We did see as to how you can use the SDK to send a message, which is called publish, to a topic. And when you're sending a message, you can define a set of attributes. And those attributes can be used within SNS to perform intelligent filtering. In the demo, Norm was actually sending two different messages, a preview build and a release build. In a release build, he actually had defined that attribute as to what type of message coming in. And if it's a release build, he actually want to get notified on an email if things did not work correctly. But for a preview build, he doesn't want to actually get, spoil his weekend. That's where the filtering of the messages come in. And you can actually process your SNS messages with .NET Lambda functions. So we did see as to when the message actually gets published to SNS, you can invoke a Lambda. And at the same time, you do get the capability to send an email or even a text notification. And recently, just last week, as Norm mentioned, there's a new feature in SNS where you can actually do parsing of the entire message body, but obviously there's some cost to it in terms of when you try to parse the entire message body. So the next messaging pattern that we're going to talk about is called message router or bus. Now this pattern is primarily used to build event-driven applications. Over the last 10 years, we have seen an increased adoption of event-driven applications. Now, within this architecture, there are three primary actors. An event producer, which is depicted as a sender, an event bus that acts as an orchestration to perform your rules processing, and an event receiver. So going back to our example of e-commerce application, how that's going to work in an event-driven architecture. So in that scenario, the order service is actually going to publish an event saying an order-created event happened. And at that point, the sender is not expecting a response or a correlation back from any of the receiver. Within your organization, once a message gets published, there could be multiple teams that are working independently, listening to the messages that are coming on the bus. So in this scenario, let's say the order created event gets published to the bus. The notification service is interested in that event. It tries to grab that message and take a further action to notify a consumer. However, the fulfillment service is not interested in the order created event. It's more interested in the event when the order actually gets processed or shipped. So it can ignore that message. So this is the primary design of event-driven application. And we have seen an increased adoption of event-driven application across the organization base. At AWS, you can take advantage of Amazon EventBridge service to implement this pattern. EventBridge is a serverless event bus service. There is no infrastructure to provision, and it scales automatically infinitely. Now, one of the key aspects of EventBridge is to ingest data from AWS services. In fact, more than 200 plus AWS services already have pre-baked integration with EventBridge. Another key capability of EventBridge is integration with third-party SaaS providers. So for example, if you are writing a .NET app and you need to integrate data from Salesforce or Zendesk or PagerDuty, there is already a pre-baked integration with these third-party SaaS providers with EventBridge. And that is one of the key shining points of EventBridge, where you do not have to reinvent the wheel to ingest data from these third-party SaaS providers. In fact, at AWS, we actively work with those third-party SaaS providers to have those pre-canned integration with EventBridge. Now, once the messages or the events gets published to the EventBridge, you can go and define rules. And if the rule matches that event that came in, it's going to invoke the right action. And this is something we're going to see in the demo, where once an event gets published to the EventBridge, you define a rule, and if the match logic is correct, it's going to start invoking the other endpoints. So as you can see here on the slide, we are depicting you can invoke AWS Lambda, SNS, or other targets like calling another API. So let's jump to the demo of EventBridge.
All right. Next slide. So far we've talked about how my team, the .NET team's build system, is taking in those messages from the release orchestrator. But now let's talk about how the release orchestrator works. So the release orchestrator, its job is to take preview messages and release messages, and we're going to call those, they're going to call into their separate Lambda functions. Those Lambda functions are going to do some validation logic on there. They're going to go look to see what are all of the queues that are registered for each of our SDKs and send the messages off. Now, to route our messages to the appropriate Lambda functions, we can use EventBus. With EventBus, we can define the rules and the patterns for those events to make sure they get filtered to or sent to the right target, in our case, a Lambda function. So let's switch over. So here we are. So in here, I've got a couple Lambda functions here. So this is my Lambda function for a preview build handler and a release handler. Now, I'm not going to go through this code because this code is very similar right now to that first demo where it's sending messages in here. What I want to talk about is how do I hook up these .NET Lambda functions to our event bus. So here's my event bus. I have a bus I created, the AWS SDK build bus. It already has one rule set up for release builds. Let's create the rule for preview builds. So I'm going to name this rule preview build. Say next. Now on this screen is where we are defining the pattern. How we're going to look at these events coming in and to know whether this rule is true or not, where we should execute the targets. Now most commonly EventBridge is used with AWS service events or third-party events. In our case, we're going to use it as essentially as a custom event. Now what you're doing on the screen though, there's sort of two stages here. First, you're going to provide a sample event, and then you're going to use that sample event to then test the pattern that you put in. So back to my handy dandy cheat sheet here. Here is what our events would look like coming into our system through EventBridge. The top stuff is the boilerplate attributes of EventBridge. We've got this detail type, which is going to let us know whether this is preview or release build. And then in the detail is all of my actual custom event data. So my pattern I'm going to use for this is going to check that detail type. So it's just going to go check that detail type to see if it's preview build. Now my use case here is super simple. I'm just checking one attribute and is it that same value? EventBridge has a lot of power with how it can search those filters. We can check the full nested level of our JSON document. We can do string comparisons. Does it make sure it starts with certain things? Do certain properties exist? There's numeric comparisons. So there's a lot more capabilities than we're using in here for our simple use case. But here I'm just checking to see if the detail type is preview build, which we can see that's what we set up here in our sample event. So if I run that test, we can see it matches. And with that, I can say next. So now if that pattern evaluated to true, it's going to EventBridge is going to execute these targets. And we can have multiple targets in our system. I only needed one target, which is to call my Lambda function. So let's see, Lambda. And you can see in that list, there's a lot of possible targets. But I just selected Lambda, and here is my preview build handler. Now, in our use case, we control both the source and the target. So I have complete control over what the message format looks like. When you're working with AWS service events or partner events, you don't get to control that format, right? The service has defined that format. And you might not be able to control what your target accepts. In that case, with EventBridge, you can actually specify a transformer here. This transformer allows you to essentially mutate that incoming event to what your target accepts. So this is a very powerful feature for EventBridge for being able to connect different things that you don't even particularly own. But again, in our case, we own it all, so I can just say matched events, pass it in just as I get it, and I can say next. I'm not going to add any tags to ours right now. I'm going to review it and say, wow, this is awesome, and push the create rule. And so now we've got our event bus set up so we can filter our events to the right place. Let's test this out. So if I go to our event bus, in the console, I can click Send Events. So it's a source, and we're going to say we're going to pretend to be our orchestrator. This is our preview. Very important for me to spell that correctly. DTOP is preview build. And then we need to pass in the details of our event. So let's take that over there. And this will center it. Now, before I push send, I'm going to start up the message processor. So that's going to go kick off and waiting for messages. Now, as I push send, we're now connecting all of our pieces that we talked about together, right? So this EventBridge is now kicking off our Lambda functions, which has added things to our queue. Now our message processor is now processing our message. Once it does all of its work, it's going to go send the results back into SNS and completing that circle. So we have all these different components that we have created, but none of them really know anything about each other, and none of them had to do any dealings with the retries and things like that. That is handled by the managed services. And I could scale with just if I adding more containers or not, I could scale each part individually. And that's how my team was able to really work well through this reInvent. reInvent is a crazy time for my team, you can imagine, of having these things. And our systems still run just fine because maybe our queues get a little longer, but we don't lose any messages, and they still all get delivered to our service teams and eventually out to you .NET developers to get your SDKs out there.
So Norm, I see the entire demo for EventBridge was done from the AWS console. Mm-hmm. Are there any capabilities in the SDK to integrate with EventBridge?
Yeah, I mean, here I tried to make the demo sort of quick and easier to visualize, but to send the events in code in .NET, it's very similar to the SNS and SQS demos we saw, where you create that service client, and then on that service client, there's the put events API, which is what that screen is doing as well. It's just calling that put events API off of the service clients. All right.
All right, thank you. So quick recap of what we covered in the EventBridge demo. We did see as to how you can define EventBridge to the AWS console. Once the EventBridge have been defined, you can actually get by default something called a default event bus. Think of this as a placeholder where your events are going to come in. There you can actually do content filtering. Now one of the key features of EventBridge that you can actually do filtering for the entire body. Now previously, as Norm mentioned, SNS did not have that capability, and that used to be one of the differentiating factors of EventBridge. We also did see that once a message actually gets to the EventBridge, you can pass the data to a .NET Lambda function. In addition, with EventBridge, you can actually do a transformation of the message. So going back to our e-commerce use case scenario, an order created event gets published. But the notification service does not understand the structure of the order created. It only needs an event that actually, let's say, needs a customer email ID, so it can send a message. So you can do a transformation of the message itself or the transformation of the event, where you take one event that came in, let's say had 4 attributes, and before it actually gets sent to your subscriber, you may only want to send one attribute. And that's what the transformation means, which is converting from one format to another. Okay? Now, we talked about the patterns and services that you can leverage to build distributed application. Right? So we talked about queue-based integration, pub/sub, using EventBridge. Now, one of the common challenges or the questions that get asked from our customers, as I build these distributed applications, how do I trace or reconstruct a chain of events when error happens or things are not working as expected? Because we added all this complexity taking advantage of these cloud-native services, or actually having a single message go through multiple layers of processing. So if things are not working, how do I quickly figure out my root cause or performance issues? Now, if you're working in a monolithic application, it's typically straightforward. You could simply open up a log file, and you can see what actions were taken in the code itself. But now we are talking about a scenario where a message gets to SNS, then there could be a bridge to SQS, a .NET Lambda function, calling another API. So a single message could traverse across multiple services. Now, this is where we are actually going to talk about observability. Now, capturing logs, metrics, and traces is nothing new, right? We have been doing this for the last 20 years as we have built end-tier applications. But the challenge becomes when you build these cloud-native applications is a common format to emit this trace data. So this is where I would like to introduce or share information on OpenTelemetry. It is an observability framework that supports 11 SDKs in 11 different languages, and it basically has an alliance of other major cloud providers as well as our partners like New Relic or Datadog. So think of this as an industry standard for sending observability data. Now, you can use OpenTelemetry to instrument and export telemetry data. There are two key pieces that we would like to talk to you about. First is the SDK to emit or generate your OpenTelemetry data, or telemetry data in a format that is compatible with OpenTelemetry. Second, once your application has generated the trace data, how do you ensure you can collect in a format and send it to different visualization engine? So if you take a look at the slide on the left-hand side, we have a simple reference implementation of OpenTelemetry. I have a custom .NET microservice. It's taking advantage of an OpenTelemetry SDK to instrument your application. And then we have an ADOT collector, which stands for AWS Distribution of OpenTelemetry Collector, which is upstream compliant with the open source version. It's ingesting the data, and then you can configure the collector to send data to various visualization engine. For this example, it's sending data to an AWS X-Ray service. So AWS X-Ray is a service to analyze and debug production applications. There are two aspects of X-Ray that we would like to talk to you about. First, once you get this trace data, how do I visualize my application architecture and the dependency tree? This is one of the key capabilities of X-Ray that we see our customers leveraging it extensively. It is called a service map. So this is something what Norm is going to show us during a demo, where your application is sending trace data. There are a lot of moving pieces for a given business transaction, but it's actually going to lay out a well-visualization engine of your dependency tree. The second aspect of X-Ray is the performance capability. So as developers, if your Lambda function that is draining the SQS queue, let's say is calling a S3, another API endpoint, how do you validate how long did it take to make a call to S3 or to an API endpoint? Doing that manually for every operation is extremely difficult. And that's another capability of X-Ray that we would like to demonstrate. Okay, Norm?
All right. So yeah, let's talk about how our build system, how we can add OpenTelemetry to it. Now, OpenTelemetry is a very large topic. We don't have time to go deep into all of it. What I'm going to focus on is first, how do we instrument our application? So for instrumentation, you can think of it in two different categories. There's auto instrumentation, and there's a lot of popular frameworks like ASP.NET Core, Entity Framework, and including our own AWS SDK for .NET that supports auto instrumentation. which means that essentially you usually include another NuGet package which has a flag that says turn on auto instrumentation. And now that library is going to start emitting instrumentation data automatically through all of the traces. So from the SDK's point of view, you'll start seeing all of your other AWS service calls, like when you call SQS and SNS, to automatically be part of your trace data. Then there's the manual instrumentation. In .NET, you use the system diagnostics classes to manually instrument your business logic so you can kind of see where your application is spending its time at and help diagnose potential errors in your system. So starting with our message processor, we have for auto instrumentation, we've included this NuGet package here to be able to enable auto instrumentation of the AWS SDK for .NET. Once we have that NuGet package there, in OpenTelemetry, at the start of your application, you're always configuring your trace provider, which has all the other settings about how you want OpenTelemetry to work, as well as where you want the data to export. We also have this method here, which is now available because of that NuGet package, to turn on the auto instrumentation of the AWS SDK for .NET. So now automatically all those service calls that we've seen us call today are going to be in there. Now, for the manual instrumentation, I've defined an activity source from system diagnostics, and this is where I'm going to start all of my activities inside my code. So if we go back to our build queue processor, you can see at the start of every loop, we're starting our activity. We're going to poll for messages. So this is going to be like the root of our trace for every one of our traces. Now, every activity we start after this point is going to be a sub-activity. So here's, we have a message, let's go process it. And I add data to these traces by adding tags on there. Like here's the message ID on there. Or if I look at my process message, you can see I've added the build IDs and the build types. This is going to allow me, when I get to X-Ray, to be able to search my system for this data to help figure out where things are going and what's happening in my system. Now, for Lambda's case, we have, the instrumentation is basically the exact same. The one difference is that you will want to include this NuGet package here, instrumentation AWS Lambda. And then when you write your Lambda functions, you're going to wrap all the logic in this trace method. So if you remember from my previous demo, I had all of the logic actually in that preview build handler. I've just kind of shoved it down one layer in the call stack to my instrumentated preview handler, and that's now what's being called as part of that trace. Doing that now, everything with that, I'm now set up for OpenTelemetry, and this trace method is going to take care of starting and stopping the root trace segment. Now, for deployment, for my message processor, that's a container. So I will deploy that with the X-Ray, or excuse me, the OpenTelemetry sidecar container. I'm using CDK to deploy it. So basically, in my CDK deployment code, I just have where in my task definition in ECS, I include that extra container definition.
So Norm, just to clarify, if you are running your workload or the processing logic in a container, we need to run the a.collector in another side, like a background job as a sidecar container.
Right. Like actually, so here is my CDK project. I'm going to show you for all funness. In my CDK project, I have a create task definition where this is where I'm adding the container definition for my OpenTelemetry container as well as my application container. That's how I deploy that. Now for Lambda, you need to deploy it with an extra layer. And so for Lambda in my CloudFormation template, I'm just calling that layer that I want to deploy it with. Both those sidecar containers and that layer is working as that agent running in the background, and OpenTelemetry is going to export all of its data to that agent, which will then send the data over to X-Ray. So let's go take a look at X-Ray. So here we are on the console, X-Ray. X-Ray is going to go up. It's going to go look at all my trace data and compute our service map for us. So this is, you can see this is our system. Now, overall, build system is still pretty simple, but you can still see here we've got, this is our Lambda function for releases messages. That Lambda function is going in and sending messages into our queue. This is our preview Lambda function, which is also sending things eventually to our queue. And down here at the bottom, this is our container, our message processor that is pulling messages from our queue and sending the results up to SNS.
So for folks, what you see, this visualization of the service map, this is automatically reverse engineered by X-Ray based on the trace data that's getting published. So exactly lay out your application architecture in the dependency tree once you start pushing data to X-Ray. Now, Norm, I see there's actually green and red out there. What does red indicate?
So the container processing messages, we can see that's got some failure in there. About 9% of the messages coming in there are failing in our case. So I can check this and look at traces to filter to see what is actually failing in our system. So these are the traces that recently failed, and I can drill down in there, and I can see down here at the bottom, this was all that instrumentation that I did here, right? You can see the manual instrumentation. I'm polling for messages, processing, and the auto instrumentations as well. You got SQS, which looks like it was doing a long poll for about 14 seconds until suddenly it found a message and returned back. We also see, yep, this one failed. I can click on there, and going through here, I can see when it happened. Here's my annotations to let me know, oh, this is a release build. And as we know, I'm not allowed to release live bits while on stage, so that's why that's failing.
So Norm, are there any other mechanisms to search for this data other than any other attributes or annotations that you can look for?
Well, so in our code, you saw we were adding all those tags. We said add tags for the message ID, build IDs. And that gets translated in X-Ray as those annotations. So I have it showing up here, but I also can search on those annotations. So if I go back to my service map, I can say annotation, and I know one of the service names, one of the attributes I added is service name. Let's see, EC2, and I can see, yep, that had a trace that recently went through. I can click on there and see, again, the same similar data. Looks like this one failed as well, and I click on there and see, oh, they've got, looks like they're sending us a bad model, and that's why it's failing for us. But that's how you can see, using all that data we have in here, X-Ray gives us a lot of ways to get an overview of what's going in our application, and then the data in there to drill down into it. Okay.
Cool. Great, thank you, Norm. So a quick recap of what we covered in the observability demo. You can instrument your AWS code automatically with the NuGet package that AWS provides. So what does that mean? So let's say within your application, you're calling AWS services like S3, or you're even calling another AWS service, another Lambda function. All that is automatically going to be instrumented. In addition, you can manually instrument your code too by taking advantage of system.diagnostic activity. You can add specific tags before you instrument your data. And then if you actually push your data to a visualization engine like X-Ray, you can use the same tags to go and search for information. And in terms of visualization, X-Ray provides you with a pretty clean and cool dependency tree of your application architecture. You can quickly drill down for a root cause analysis. For example, we did see green versus red, so you can see where the errors are coming from. So we have actually defined a set of links here that gives you additional information to build distributed architecture. So I'll encourage you to take a quick photo of this.
I just want to call it that bottom one. I'm very biased there because that's coming from my team. We're looking at creating a new library to try to maybe make all of our messaging libraries be more fitting into more modern .NET schemes using dependency injections and all those things. So it's a design doc we have out there, and for the developers in the audience, I would love to get feedback on that to see, one, is that useful for you, and what other things you would like in it. So.
Cool, thank you. All right, folks, thank you for coming over. We really appreciate your time. There is a link to the session survey. We would love to get your feedback on the session. And thank you again, and have a great rest of the day.
Thank you. Thank you all.